Hello everyone. Here we'll see a problem on mesh analysis. So the question is, write the mesh equations for the circuit shown in the figure below and determine mesh currents using mesh analysis. So this is the figure which is given. Here you will see that you have three loops. So you have three loop currents, I1, I2 and I3. But actually in this figure you have only two loops. Why? Because in the first loop you have a current source. As you all know, whenever there is a current source, you cannot consider that as a closed loop. Okay, why? Because you don't know the potential drop across the current source. So for that reason you cannot consider this as a loop. So in this figure you have only two loops, that is this one, the second one and the third one. You have only two loops for the loop currents I2 and I3. Now here the value for I1 can be calculated directly from the current source. So the first step is, what we'll do is we'll express the current source in terms of the loop current before applying the KVL. So before applying the KVL to these two loops, what we'll do is we'll find the value for I1 in terms of this, or the value of this current source in terms of the loop current. So we can write it as I1 is equal to 10 ampere. Why I have written I1 is equal to 10 ampere? Because the direction of the current I1 is in the direction of the current source 10 ampere. So we can write it as I1 is equal to 10 amperes. So take this as equation number 1. Now next step is, again we have to redraw the figure which is given in the question. We'll name all the nodes or the vertices, you can say A, B, C, D, E, F, G, H. Okay. Then after this we have to assign the polarity of all the network elements present in the circuit. We have resistors and the voltage sources. So we'll first consider this loop, that is B, C, F, G, H. Here the current, that is the loop current, is I2 and the direction is in the clockwise direction. So considering the direction of the flow of current, we will assign the polarity to the network elements. So this will be a plus and a minus. Already the polarity is there for 10 voltage source, so we will not assign anything to this. Then again you have plus to minus. Okay, the current flow, the direction of the flow of current is clockwise direction. You have to assign the polarity of the network element according to the flow of the direction of the current. Okay, next come to this loop, that is C, D, E, F, C. Again you have the loop current as I3 here. Now depending upon the direction of the current I3, assign the polarity to the network elements plus to minus, that is plus and a minus. Then here you will be having a plus and a minus. Okay. Now what we'll do is we will apply KVL to these two loops. So here you can see for loop B, B, C, F, G, B. Okay. So here I have written it as minus 2, because plus 2 minus, we are in currently in this loop, second loop. Okay. So we'll consider these polarities inside the loop. Now plus 2 minus, there is a potential drop, therefore we have to write or we have to take the sign as minus, because we are going from plus to minus, you have to take the sign as minus. So it is minus 2. Now here this is common, this branch is common to both the loops. So the resistance, the resistor, it is common for both the loops and it is associated with both the loop currents. And currently we are in this loop, therefore we have to write I2 first and next I3. For that reason we have written I2 minus I3. Okay. So it is minus 2 into I2 minus I3. Next comes the voltage source, plus 2 minus is there, therefore you have to write it as a minus. Then comes this resistance which is common to first and second loop. Actually this is not a loop, but it is common to both these and it is associated with both the loop currents. Therefore what we'll write it as, plus 2 minus will be a minus because there is a potential drop, and then I2 minus I1. So I2 minus I1 is equal to 0. After that simplify. Minus 2 into I2 is minus 2I2. Minus into minus is plus. 2 into I3 is 2I3. Minus 10. Minus 3 into I2 is minus 3I2. Minus into minus is plus 3 into I1 is equal to 0. So then you have to simplify this, and this will be minus 2I2 and minus 3I2 will be minus 5I2, and here plus 2I3, you have only one I3 term, therefore it will be 2I3 minus 10 as it is, and here you have 3 into I1. We already got the value for I1 as 10 amperes here. I1 is 10 amperes. This value we will substitute here. That is 3 I1 is there, no? 3 into I1, 3 into 10 is equal to 0. Now this will be minus 5I2 plus 2I3 minus 10 plus 30 is plus 20, and we'll transpose this on the RHS side. So we'll get it as minus 20. So this is your equation number 2. Now we have to apply KVL to this loop. That is the loop with loop current I3. So here loop I have redrawn here, just this part, third loop. So it is C, D, E, F, C. That is the loop with the loop current I3. Okay, C, D, E, F, C. So here it will be plus 2 minus in the direction of the current, flow of current. So plus 2 minus, we'll write it as minus 3I3, 3 into I3. There is the potential drop, so minus sign. Next, minus to plus we are going, we have to write it as plus 10. Plus 2 minus we are going, we have to write it as minus 2. Now this is associated with two loop currents. So it will be I3 minus I2. Why I3 minus I2? Why not I2 minus I3? Because currently we are analyzing this loop, or we are applying the KVL to this loop. So we have to write the loop current for this first, then next this. So we have written it as I3 minus I2. Okay. Now, next, simplify this. When you simplify this, you will get this equation. Okay. So you got equation number 2 and 3. Sorry, this is equation number 2 and this is your equation number 3. Okay. I have written it once again. This is equation number 3. This is equation number 2 on the previous page. Now you have to apply the Cramer's rule for this, and you have to get the value for I2 and I3. So for Cramer's rule, first you need to find out the value for D. So value for D, it can be obtained as here the coefficient of I2, coefficient of I3 for the first equation, that is second equation, coefficient of I2 and coefficient of I3 for the third equation. So coefficient for I2 for the first equation, that is this equation, is minus 5, I3 is 2, and here it is plus 2, and for I3 it is minus 5. Now you need to find out the value of this determinant. Minus 5 into minus 5 is 25. 25 minus 2 into 2, that is minus 4. 25 minus 4 is 21. Then you need to find out the value for D2 because we want the value for I2. So D2 is, you have to replace the first column element, that is the I2, coefficient of I2, by the constant on the RHS side, that is minus 20 and minus 10. So the first column elements are replaced by the RHS side elements minus 20 and minus 10, and these two elements remain same. Again, find out the value of the determinant, you will get 120. Similarly, you need to find out the value for D3, okay, determinant. Now here we want to find out the value for D3. So these are the, that is first column elements you must keep as it is. Second column elements are replaced by the constant on the RHS side of the equation 2 and 3. You solve this, you get 90. Now we need to find out the value for what? I2, that is current I2. Current I2 is D2 by D. D2 we got it as 120 and D is 21. Okay, here D is 21. So you get it as 5.7142 amperes. Similarly, you have for I3. I3 is D3 by D. D3 is 90. 90 by 21 is 4.2857. So all the currents you got it as positive. Therefore, I1 is equal to 10 ampere, I2 is equal to 5.7142 amperes, and I3 is 4.2857 amperes. So this is a problem about the mesh analysis. Hope you all have understood. Thank you.